Good afternoon, everyone, and welcome to the fourth in a series of webinars to celebrate British Science Week 2021 and the theme of Innovating for the Future. I'm Claire Willis from the North East STEM Ambassador Hub, and I'm going to be introducing today's speaker, Paula Mcmahon from Sir Robert McAlpine, who is going to wow us all this afternoon with engineering. But first, a little bit about Paula, as sometimes I just don't know how she manages to fit everything in. Paula is a civil engineer who has worked on a variety of projects throughout the world, including the Thames Barrier and the first nuclear power station built in this country for decades. She's an experienced and enthusiastic STEM ambassador who volunteers and helps students with the leap into the real world. She loves people who invent and has even travelled to London to see the Red Bull soapbox race. Paula has contributed to several events promoting diversity in all forms and is also very passionate about the need to address the climate crisis. Along the way, she has gained many awards and accolades, and you can see those on a shelf at the back. And she's also on the Northern Power Women Future List. She is passionate about engineering and is going to talk to us today about just how exciting it can be by showing us a range of cool engineering innovations that I am sure will amaze us all. Don't forget to type any questions you might have in the chat facility and include your school name, and I will try to ask Paula as many as I can at the end. So, without further ado, over to you, Paula.
Thanks, Claire, for that lovely introduction. So I'm going to share my presentation so you can see. We are going to talk about engineering to wow. Can you just confirm you can see that, please, Claire? Am I going to assume?
Yes, Paula. Yeah, it's there.
Thank you very much. So, as Claire mentioned, we're here to talk about innovating the future and what engineers do. But before that, let's have a little bit of a welcome. So Claire's already introduced myself. I'm also going to be helped in this presentation by Maria and also Mimi. Let's hear a little bit from Mimi. Oh, the technology. Excellent, thank you, Mimi. And there'll be some other people that we'll hear from that are from Sir Robert McAlpine and also from other places all around the world. So what we're going to talk about. So it's British Science Week and we're going to talk about innovations. But I think engineers are the ultimate problem solvers and innovators. So we'll find out more about engineers and how engineers will shape the future for everybody. So we'll talk about what's engineering, we'll talk about how important engineers are, we'll have a look at the different types of engineers because there's lots and lots of different engineers, we'll have a little chat about busting some of the myths of construction, and we'll have a look at some exciting projects and engineering innovations. And then we'll obviously have our questions at the end. So as Claire said, if you put them in the YouTube chat, we'll get to as many as we can before we finish off. So, engineering, what is it? So we're going to look at these different types and I'm going to explain sort of how fantastic I think it is and the future of it. So let's ask Mimi and she'll give us a little bit of insight into why she thinks engineers are important. But we'll also have a look at some websites such as Tomorrow's Engineers, which is now on the NEON website, NEON Futures, and have a look at what interesting engineering says. See if you can see a theme through all of these different things. So Tomorrow's Engineers believe that engineering is exciting jobs that make a difference. They say that the work that engineers do affects billions of people. It's creative and hands-on. It's about solving problems, designing and improving things. They make a point that engineering is behind absolutely everything. Everything from your smartphone, hairstyling products and the lights that you switch on and even the shoes on your feet. So if you enjoy science, maths, design and technology or even computing at school, you might be able to be an engineer that's designing anything from cutting edge technology to providing water in drought plagued countries. So have a look at the NEON Futures for more information on that. But let's see what Mimi wants to say. So I asked Mimi,
Paula, we can't hear Mimi's answer.
Oh dear. Right, so I am, so I'll explain what Mimi's going to say. We did test this out and we were supposed to hear it and I could hear it, but never mind. So Mimi laughed when I asked her how important engineers were, and she laughed and just said she can't even imagine a world without engineers. They're that important, and they're involved so much in everything that we need to do. So that's how silly a question it sounded to Mimi that she actually laughed when I asked her it. So interest in engineering said basically that engineers are not only important on what we've done now, they're becoming increasingly more important. So we're becoming more and more dependent upon technology. So engineers are required more and more. And if you have a look at interest in engineering, you can see that engineers are getting involved in agriculture, which is farming, which is where your food comes from, education, and also the health sectors as well. So in answer to the question, how important are engineers? Well, they're needed now, they're needed for the future, and so I think, and I hope you agree, that engineers are very, very important. So let's have a look at what engineering is, and fingers crossed this sounds going to work. If not, what we're going to do is we will send the links around to everybody so you can watch these things yourself, and you can watch them in your own time afterwards. But hopefully we're going to find out in our next slide what it is. And Claire, tell me if you can hear it. Can you hear the music? Yes or no?
I can't hear the music. The video's playing. I can't hear the music.
Right. It's only playing music at the moment. Let's watch some of it, and you can see all of these different things that engineering is. But obviously you won't be able to hear the people talk. But there it is again: designing, building, solving problems. So Jasmine's a mechanical engineer. That's telling us that you can find things everywhere. Cars, even your toaster, shoes, houses, buildings you're in. There's Demi, a petroleum and humanitarian engineer. It's even paint. Amy's a chemical engineer. Brittany's a mechanical engineer. They're everywhere. So we'll stop that there because a lot of this now is talking. So I'll send the link later so you can watch it in your own time. But what do you think it takes to be an engineer? So have a think of that question while you're listening to this, and maybe you can ask some questions at the end relating to that. But anyone can be an engineer if you've got that problem solving mentality, if you're good at the maths, computing, if you like that sort of thing, then engineering's for you. So there's lots of different types of engineering, and some of them were mentioned in that clip: mechanical, environmental, biomedical, computer, agriculture, electrical. I'm a civil engineer, and there's lots of different types. So let's have let's have a look at some of them different types to explain a little bit. Can't go through all of them because there's so many different types of engineers. So there's mechanical engineers. They say they build the world around us, from anything from the tiniest nanotechnology through to cars, buildings, aeroplanes, and even space stations. So it's a combination to study it of math, science and computing, but also study of machinery, how things work, how you can manufacture and make things, and not just make them, but maintain them as well, so they keep on working for years and years and years. So it's a limitless subject which plays a role in everything from vehicles to cities, and energy to artificial intelligence. So military, healthcare, and everything in between. And that theme of being involved in lots of different things and spreading across lots of different types of things that get built, designed and maintained is pretty common through lots and lots of different disciplines of engineering. So let's have a quick look at electrical engineering. So we were going to hear from an electrical engineer, but since you can't hear it, there's not that much point. So I'll skip over the next slide, and again, we'll send you the YouTube links. But our electrical engineer will tell you about the day in his life and explain that he looks after a plant where it's almost like a mini city, and he loves his job. And you'll find that if you look for lots of things on the internet, if you look for YouTube clips, role models, that it's very much people that are enjoying the job and find the variety and the fact that it's different every day. They really, really do enjoy it. So let's skip over that one. So biomedical, a lot of people wouldn't even think that engineering's included within sort of the medical field, but what do people do that have unfortunately lost a limb and need an artificial limb? Then that's where biomedical engineers come in. So again, the word is there, is called an interdisciplinary field. That means that it's lots of different disciplines. So it's not just one thing, it's not just a boring job that you do day in, day out. There's lots and lots of different things involved in many of these sectors of engineering. So the biomedical engineers look at the mechanical engineering, but in combination with biological systems. So that's basically the human body. So they'll look at biology, engineering, physics, chemistry and maths to better understand how people can basically live a better life. And again, that's a theme that's for every type of engineers. So he's civil engineering, my personal favourite, that's what I am. Again, we're not going to see the next clip and we'll send you the YouTube clip. But civil engineering, again, covers lots and lots of different things. Without civil engineers, you wouldn't have water to drink, you wouldn't have electricity, you wouldn't have the building that you're in, you wouldn't have roads, trains, or anything like that. We say we build infrastructure, and infrastructure is the things that you need to basically live your life. And again, we design things, we build them, which is construction, and we also maintain them. So I'll skip over that. So I think engineering is totally fantastic. So the E in STEM is absolutely my favourite. And I think, well, it totally wows me every day. But let's have a quick look at construction. So lots of people think construction, building things, is actually a very, very dirty thing to do. And lots of people, when you say engineer or construction, just thinks of hard hat and a high visibility vest. But there is tons and tons of jobs in construction, and construction sites aren't as mucky as what you might think. So let's have a look at so if you just look like the Sir Robert McAlpine as an example of a builder, you can have a look on our website, and we've got lots of different things there. And yes, there's people in that picture wearing hard hats, but if you actually look at our construction sites, they're not that mucky. Again, we've got a nice video showing you different things, and I'm going to stop it at some point because you won't be hearing this now, that I'm guessing. But we're an old company, we've built lots of different things, lots of innovations, there's that word. Trains, offshore, buildings that get used for football, for concerts, big and small, hospitals, shopping centres, Eden project, so that's like some big greenhouses, roads, airports, the Olympic Stadium. We also inspire future generations, which is why I'm here to help.
Paula, we can hear some sort of music just in the background there. I just wonder if it might be a volume issue.
Sorry, Claire, I could hear you were talking, but I couldn't hear what you were saying. Say that again.
Sorry, there was a little bit of music in the background there, Paula. And it's a volume issue. I'm not sure. They just
don't know. I
Don't
could
know.
hear it super loud, so I was trying to talk while pretending I couldn't hear it.
Yeah.
So I'll just assume we can't hear anything, and we'll send all these links out. None of it's a problem.
Brilliant.
But you can see, just looking at the variety that Sir Robert McAlpine do, basically, can you imagine a world without engineers? The Olympic Stadium, shopping centres, airports, and everything. So again, this is a common theme through all types of engineers and engineering. This is what we do. We design, build, and maintain. So this is just a quick look at our website to look at different things. So this is the sort of design side of our business. So even though we do build things, we have to have design to help build things. We need to make sure that that we have support, because things that get built have things that you end up seeing. They're permanent things, but they also have temporary things that need to be designed to help them stand up whilst they're being constructed, because safety's got to be totally at the forefront of everything we do. The main thing we do, though, is definitely build, and there's lots and lots of different projects. So some of them you saw in the video, but there's lots of different things there. And again, you can have a look on the website. But shopping centres, places where people live, places where people work. The Royal Albert Hall is a great project. The Royal Albert Hall is a really old building that needs to be refurbished. So we need to bring it into modern times. So it has pipework and things, so it can be you know, kept warm. And you'll see the video coming up on the next slide. And again, I'll assume you can't hear it, but you'll see from this video that we have to plan things quite a bit, and this is the same for any type of engineering. There's lots of computer work that goes into planning these sort of works. Then big yellow things there are props. They're our temporary works that we make sure that people in that construction site can be kept safe. So imagine working on a project like that. Super cool, and it'll be used by thousands and thousands of people in years to come to watch all sorts of different concerts at the Royal Albert Hall, which is a really lovely historic building, which is cool as well because it's round. I think it's cool. So again, lots of different things, and although that's a construction site, there's not that much dirt and muck. It's very clean, very well organised, because we can't have it so it's unsafe for people. We need to have it so it's nice and clear so people can walk around. And yes, people are wearing hard hats and high visibility to make themselves visible to other people, but they're certainly not the mucky building sites that you might imagine. And if you're a civil engineer, this is the sort of project that you can work on. Drainage there, everybody needs drainage in their own houses, in the buildings that they're in, and there's lots of different things. So again, I'm going to stop that there. And concrete, civil engineers do a lot with concrete. So let's have well, we won't listen to what Marie is going to say, but we'll go on to the next slide. I asked her what her normal day, and she said it's management based, but she's just setting out quality checks. She hosts meetings with different trades and considers health and safety. She prioritises works, makes sure there's no issues or delays, and she gets feedback from the teams. She thinks the job is exciting, and lots of engineers say the same. Always challenges and puzzles to crack. So she solves them as either herself as a team, and it's versatile. In the future, she knows that lots of doors are open to her, and she knows that if she changes, her career can change with her. And that's the same with lots of different types of engineering as well. It's very, very exciting that people that work in it, but it's exciting, and they know that it's versatile, it's flexible, and we can change. Because we have to change, because we're serving the needs of what people need, and that changes all the time as well. So maintenance as well, this is actually the project that I work on. And so we look after the road and the bridges and the lights and the trees and the grass and everything else. And every engineer has to think about the maintenance of everything, whether it be a smartphone, even the shoes that they design, everything needs to be maintained. And the mechanical engineers say that that's what they get trained in as well. So we won't listen to who wears a hard hat, but not everybody in that picture does wear a hard hat. Unsurprisingly, Megan does. You can see her in her high visibility thing. She spends a lot of time on site as a site engineer. Lucy doesn't wear a hard hat as an office manager. Richard does, as a design manager, sometimes wear a hard hat when he's going out to measure things, but he doesn't always because he often works in the office. And Maria wears a hard hat every day, and she says she absolutely loves it. So construction sites aren't as dirty as you might think. Then there's lots of different construction sites that we work on, including, as I've said, the Olympic Stadium, and also putting a retractable roof on Wimbledon. Now that's an innovation. So retractable roof is something that gets taken on and off. So when it rains, in Wimbledon, they can actually put the roof on, and that was a really cool project, I think. So we're not going to take a look at that, but there's lots of other types of really cool projects that's in engineering. Just look at them buildings. They're not boring. Most of them aren't even made out of red brick, like you would think that a building would be made out of. They're not square. Some of them are tall. Some of them even come back on themselves. Some of them have holes in the middle. And lots of them have different innovations. There's one of them buildings there that even just turns constantly. So if you're in a room, you'll get a different view every hour of the day, which, if you don't think that's exciting, well, let's have a chat, shall we? So looking at some innovations, just the wildest innovations of 2020. Again, you could literally spend all your life looking at all the different innovations. So there's lovely, cool buildings there, but engineers have also invented food, such as ice cream that doesn't come from cows. That is a really cool building that has a walking trail. It has a slope on it, so you can actually put on sort of roller skate type skis and roll down it. And it's also extremely environmentally friendly, that building as well. It doesn't have any, it has carbon neutral, which is something that we're going to have to consider more and more. Here's some more food related things. That's bacon that doesn't come from a pig. And there are other things that engineers have invented, things that you wouldn't even think that an engineer would get involved in. Okay, so there's some low calorie sugar. Who wouldn't like the idea that they can have something sweet without the calories? But even art projects need to have engineers to be involved. These things wouldn't stand up at all if they didn't have somebody thinking about the problem of making sure that they stay where they are in all weather conditions. Just think how windy it gets sometimes, and the different temperatures and things. So as temperatures get hotter, things expand, and as they get colder, they contract. So all of them things are problems that need to be solved, and engineers are the people that solve them. So to summarise, engineers are problem solvers that design, build and maintain just about everything. And I totally love engineers. Well, engineers are not just problem solvers, we're innovators as well. So solving a problem often requires you to create something new or innovative. So just to explain that a little bit, invention is something that somebody comes up with completely new. So think of the ice cream. So ice cream already existed, but it's innovative to think that you can make ice cream without needing a cow. Yeah, so it's using things, it's not making things from scratch, it can be making things better. So engineers, they may not have been called engineers, were the inventors of the wheel to begin with. Yeah. And they won't have been called engineers to begin with because they'd have just been somebody that was a good problem solver and an inventor. But imagine a life without a wheel. What have we done to innovate that wheel all the way through society? You couldn't do anything without a wheel at all. You obviously couldn't use a car or a train, but it's more than that. There's wheels inside of other things that you won't even see. Inside of every motor is wheels inside of it. Then there's concrete. Just think about concrete. So engineers invented concrete, but we've innovated in concrete technology over many, many years, and it's now stronger. We can make it lighter, we can make it more sustainable, so more environmentally friendly, by doing things like replacing cement with other things to make it still as strong, but not adding as so much carbon to the environment. So Mimi, who was in the pictures before, she looks at concrete all the time. She looks at the quality of concrete, so she loves concrete. Engineers invented the train, and that picture there is quite an old picture, but think about what trains look like now. They don't really look like that anymore, and so, you know, we've innovated all the time, and now you get different types of trains. And TVs, engineers invented TVs, and again, they don't look like that anymore. They're now much thinner, and they sit on your wall more like a picture, and you can get smart TVs that have technology, and you can use them to link to the internet and everything. Just think how much they've been innovated over the years. And obviously, looking towards the future, we're going to do more and more in terms of innovations, and in terms of digital technology and artificial intelligence and things like that. So again, just typing in searches for innovative engineering. We've got 3D printing that we can do. We've got train tracks that float. Who would have thought it? If that doesn't make you go, wow, I don't know what does. Superconductive materials, so things that conduct electricity and heat very quickly. Hydro, solar panels, all sorts of things that are smart rings, so you could pay for things with just having a ring. Everything to do with energy, drinking water, all sorts of different things. So engineers are innovating all the time. And who would have thought one engineer would even be looking at folding paper in order to think how you can have a bridge that's more innovative, a bridge that you could fold, put on the back of a truck, and then use it any way you wanted to. Honestly, if that doesn't make you go, wow, what will? So looking to the future, we're going to be looking more and more towards technology and looking, you know, making it more and more in our day-to-day, and maybe even looking further ahead, we may even be looking more and more into going into space. So who knows, the future, what's it going to look like? So sustainability is something that we all need to think about, and here's some sustainability innovations in civil engineering. So we're looking at plastic roads, so taking a product that's a waste product and using it for something that is useful and it doesn't use oil. Green roofs, which is putting grass and things on roofs. Floating homes, who wouldn't want to live in a house that floats on water? Vertical farming, so looking at things that makes better use of the land by growing things up instead of along, and harvesting rainwater. So instead of all of that rain coming on your roof, going down into the drains, let's harvest it and let's use it for things like flushing toilets. Again, there's going to be lots and lots of engineers looking at technology, so digital twins, so making a computer program, a computer package that looks like the building, so we can have lots of information embedded in there, so we can try things out, and it's a good record of everything that we can try things out before we build it, and it's a good record of everything that's been built. Again, we get that artificial intelligence where computers will be doing thinking for us, and lots of other things, including robotics and printing. And they call it disruptive engineering because they change things so much, they disrupt the way that we work and how we're going to think and how we're going to live going forward. So a good example of that is the smartphone. That was a disruptive technology. So before the smartphone, before the iPhone, who would have thought that you would have carried around in your pocket something that would replace maps, the telephone, computers and everything? So the future of engineering, there's lots of different things that you can look at in the future of engineering. Aerospace engineer on Mars, global food, smart cities, everyday electronics and sustainability and software engineering. So there's lots of different things that we know that the future of engineering is going to help us even more than it does today. So I think we can all agree that engineering totally wows. It's essential now. It's creative. It is definitely innovative. It's very varied, it's for absolutely everybody, and it's needed for the future. So at that, I am going to hand back to Claire and say, do we have any questions?
We certainly do, Paula. We've got lots of questions for you. And yeah, apologies for the videos. We did try it.
We tried it, we tested it, but sometimes the technology doesn't work. So we were innovative, Claire, and we just ploughed on regardless, and we just solved the problem. And everyone can get the links later, so none of it.
Well, that's it. So what we've said is we'll share that presentation if you're happy with it, and the links, and then everyone's got it and can use it and whenever they want to. So onwards and upwards. So first question, Paula, why did you become a civil engineer?
So I sort of fell into it, and I think you'll find if you ask many people that when they were, how they ended up in the job, they'd say the same. But the reason why I fell into it is because that's where I had my experience at school. So I did a week's worth of experience when I was at school at my local council. And I totally loved it. It's totally, this is what I want to do. And so I applied for being an apprentice at the local council, and I got it. And that apprenticeship was for a civil engineer. So I didn't set out to be a civil engineer, but in speaking to adults and in speaking to my careers officer, we realised that sort of engineering was what I would probably enjoy, because I was good at problem solving, good at maths, I like sciences, and so that was a natural fit. And so it was my work experience that got me the job, and it was the job that made me a civil engineer.
So really important to, even though you're quite young when you choose which works experience placement you want to do, it's obviously really set you on your career and your future career, hasn't it? So it has, yeah. Really important for the students out there to think about a works experience placement.
It is, yeah.
Second one, so have you found it difficult as a female in what is often perceived as a male-orientated industry?
I wouldn't say difficult. I think there are some difficulties, because a lot of people think that that you're a bit unusual, and sometimes if I've walked on a new building site, they'd like, look, and go, oh, who's this? But I wouldn't say it was difficult, like really difficult. But yeah, there are definitely differences, and there's lots of people that find it a surprise, but that's less and less now. I mean, I'm pretty old. I've been doing this job for 30 years, and so obviously it was a lot more unusual when I was doing it, but since there's a lot more girls in the industry now, it's a lot more common and it's easier. So for example, when I first went on building sites, there wasn't any girls' toilets, and boys' toilets were pretty smelly. So I used to have to go to, like, I used to have to find like a shop or a cafe that I'd have to ask if I could use their toilet. But now, not a problem. All of the sites, certainly in our company, have, dedicated ladies' toilets. They're lovely and clean.
That's a bonus, isn't it? Wow, no ladies' toilets, goodness. But we have, as you say, come on quite substantially since 30 years ago. You don't look that old, Paula. So if students, the students that are listening, what advice would you give them to get into engineering? So what GCSE and A levels should they concentrate on taking?
Right, so first and foremost, the route I took was the apprenticeship, and then I did an ONC, and then I did a degree. But you don't actually have to do that route. There's many different routes into engineering, and you don't have to do a degree at all. There's different levels that you can stop at. So you don't need a certain sort of a grade really of anything, because you can work to most people, as long as they're reasonably okay in sort of maths and sciences, can work towards being an engineer of some sort. My suggestion is that you speak to people at home and people at school, and you'll do lots of research. So research, look at some of the websites that I've linked to and look at others as well. So look for the different sectors. What do you fancy doing? Look for apprenticeships, because apprenticeships are really good because you'll learn while you're earning. But the thing is that any of this, you're not necessarily going to get your plan A. So make sure you have several options. So you might choose, say, an apprenticeship as a first option, but there might not be anybody offering them near you or in the area that you want, or you may not just get the job. You know, these things happen. Not everybody can get everything that they want. So then look at local colleges and things like that. Now, each of the colleges and each of the courses and each of the apprenticeships will have their own entry requirements. So you've just got to check to see if you meet that criteria. And life is full of a combination of hard work, which you obviously should always strive to do, but also a bit of good luck and a bit of opportunity. And you can enhance your options by looking around more and doing this research and putting forward the best CVs and the best application forms that you possibly can. But as I say, sometimes things just don't work out. You were just unlucky and you just didn't get that job. So make sure you have some fallback plans. But the routes can be varied. You can go through the academic route, you can go through the apprenticeship route, you can stop and start. I know plenty of people that are not doing the job now that they started off with leaving school. So don't worry if things don't go to plan. Life's a journey. So just take every step as it comes. Look for the end goal, but and just look in detail at the next step and see what happens.
Brilliant. So it's just about seizing opportunities, isn't it? And you know, you say those links that you've got in your presentation are really great links for people who are considering going into a career in engineering. You know, use those links, use the information that Paula's talked about today. A question from Jeremy Harmsworth. Paula, what's your favourite project that you've been involved with and why?
Wow. So I've been involved in lots of different projects. I loved working on the Thames Barrier because that's a really iconic structure, and I got to go underneath the river in London, so that's pretty cool. I loved working on the nuclear new build stuff because I was involved at the very early stages. So all the work that I did as the sort of lead engineer on that job has shaped that whole project. Hundreds of millions of pounds worth of project has been shaped by decisions that I made, and who wouldn't love that? But in my heart, I love working now at Sir Robert McAlpine, and my first dealings with Sir Robert McAlpine were on the SNF site at Billingham, where I was the design manager and then I was the construction manager, and Sir Robert McAlpine actually worked for me on that project. And so by working with them, I liked the company, and so I ended up applying for a job at Sir Robert McAlpine, and so now I'm working on the A19 project. So I would say every project I've enjoyed in different reasons, and the ones that have left a legacy are the ones that you sort of really look back and say, I'm pleased I did that.
Fantastic, yeah. And I mean, some of those images that you showed, Paula, the engineering, it's just phenomenal. It's, you know, the things that you can build and do is just absolutely incredible. And the students that are watching today, you know, they could be part of that in the future, you know, a construction that we haven't even thought about at the minute. So, you know, brilliant. I'm going to ask you this question, but I think you're biased. How good is it being an engineer?
Well, I said that today, if I don't prove to you that engineering is wow, because it's just brilliant and it's the best letter in the STEM word, then I think I've proved that. I think it's pretty cool being an engineer.
Yeah, fantastic. Lady, so from Baden Powell Primary School, so what problems have you solved? So I mean, you've solved loads of problems, Paula, but I guess sort of which one's sort of, which maybe the most difficult problem that you kind of thought, oh goodness, how on earth am I going to be able to solve that? So what's been the biggest challenge, I suppose?
That's hard to say because there's been so many. So as engineers, you solve problems every day, really. Some of them are obviously very, very small, but some of them are rather large. It was quite cool on the SNF site, and the the problem was we had some massive tanks to build. I mean, tanks that were much bigger than Olympic-sized swimming pools. And how do you build something that's so big and so buried in the ground? So the solution that was come up there was a 50 metre, so 50 metres is huge, your whole school will probably fit in it, diameter sheet pile wall that we sunk into the ground and then dug everything out. And it was that tall, we had 4 flights of stairs going down to the bottom of the excavation. So that was pretty cool.
Wow. So I'm sort of going back to Sanonia, I know you're very passionate about diversity and women in engineering. So there's a question from Sarah John here. I don't know if you know the answer, but it might be a percentage that you might be able to. How many women go into engineering these days?
So it's a complicated-ish question because it totally depends on the sector and even geography in the country. It varies dramatically, but roughly speaking there's about 12% female engineers, but again it varies per sector and even per discipline within each sector. So for example, in construction there's less than 1% of people on the tools that actually work on construction sites as a construction worker, and some sectors have 45%, but generally speaking it's sort of 12-ish, 14-ish%, so round about 1 in every 7 throughout all engineering types are female. But given the fact that as a population we're ever so slightly more females than males, that's quite a bit off the mark. We're approximately 51% of the population are female and 49% are male. So we have a long way to go, ladies, to get ourselves so we're equal compared to society, and that's where I would like us to be. I would like the workforce to reflect society. The reason being is we make so many decisions every single day that affect society. If we don't have the amount of the same percentages of people in there of all different types, then we won't be making decisions that represent them. So for example, if you're building a building, if you don't have somebody there that knows what it's like to say be in a wheelchair or not have to be partially sighted, how do you fully accommodate their needs? So that's the reason why it's important to have a diverse workforce.
Yeah, great. I think my dog's got something to say about that.
I think we agree. The dog agrees.
Well, a really great question actually from TIG Federation. So how do you make yourself stand out from the crowd and get the jobs, and have you ever gone for a job and not got it? So
the second part of the question, absolutely gone for a job and not got it. Yeah, again, it's a combination of luck. You don't know who else you're against. They just might have a better set of experience than you and be more suited to the job. These things happen, which is why you shouldn't always rely on plan A. But to make yourself get the best possible options for anything is all to do with preparation and planning. So just remember that the people that are going to be looking through those applications, those CVs, what's on that piece of paper or entered onto the computer screen is all they know about you. Yeah, they don't know any more about you. So make sure it's the best possible version of yourself. Don't just say, I'm leaving school and I'm predicted this number of GCSEs. Who are you? What do you like doing? Why are you applying for that job? Have you looked at that company and said you're interested in working for them because you like that project that they've worked on, because you want to make a difference? So make it so it's a bit more personal, and so it gives that best possible version of you. Get people to read through that. So, because often you read your own stuff and you read what you think it says instead of what it actually says. So get other people to give you constructive criticism. And prospective employers may well do an internet search on you. So just make sure that anything that's out there in the public domain, on your social media profiles and things like that, have a look through it. And that joke that you had between you and your friend that may have been absolutely hilarious at the time may not sit very well with a potential employer. So if you do all of them things, you are massively increasing your chances of being successful in whatever you do. But always have plan B, plan C, and even a plan D, because plan A doesn't always work out. It hasn't for me, it won't for you, Claire. There won't be an adult, I think. There'll be very rarely have an adult that'll say everything that they wanted worked to plan.
No, you're right, and that's life, isn't it? And then we've all been through a terrible 12 months, but that's really shown people's resilience and the challenges that we've all faced. So, you know, that's great advice. And I guess sort of if we've got young people sitting there going, you know, I really want to do what Paula's doing, what sort of piece of, if you could just give them one piece of advice. I mean, you've given them loads of advice there, but just one piece of advice. What would you be saying to them?
Go for it and follow your dreams, totally and utterly. And do all of them other things that I've said to increase your chances. But there will be people along that I've had people that's told me I shouldn't be doing certain things because I'm female, because I'm younger, because I'm whatever. But be yourself, follow your own path. Don't follow everybody else's. You know, you might want to follow other people, that's fine. But if that's, make it your decision and follow your own path and your own dreams.
Brilliant. Well, I know we're so lucky to have you, Paula, because, you know, this week, well, every week for you. So we're really delighted that you could take some time out and share your experiences. Actually, there's a one last question, which is always the one you get asked, and we haven't been asked it yet, but here we go. What's the expected salary in a job like yours?
So again, that is really is a how long is a piece of string. One of the good websites to look at is the .gov website for finding apprenticeships. I'll dig out the link and I'll get it added to the back of that slide set. And there's a couple of good websites that explain to you what different types of jobs are and what the expected salaries are. I think for a civil engineer, I think they say that the salary is something from like 28 to 65,000. Again, that's a massive range because it totally depends on job function, experience, qualifications. You know, so I've been an engineer that's been responsible for 200 and odd people on site. I've been a design engineer that's been responsible for 50 people in offices. I've been responsible for hundreds of millions of pounds worth of work on certain days. So obviously them sort of jobs attract a higher salary. But I've also been a design engineer where I've sat there and done my own work and worked for other people when I was younger and had less experience. So it really is how long is a piece of string. But I will ensure that there's links added to the back of that slide pack so you can have a look to see what the different salary ranges are for different types of jobs.
Brilliant. So so the Paula's presentation we'll have on our YouTube channel, and we make sure all those links either get directly to you teachers by your email that you gave when you registered, as well as having it hosted on our YouTube channel. So thanks for joining us this afternoon, and Paula, to yourself, once again, thank you so much for your time. You're 100% dedicated to everything that you do, and you're quite rightly have got all those awards behind you. I'm sure there's others that you've hidden. So don't forget, everyone, join us tomorrow morning at 10 o'clock, particularly those people who are runners. So we've got someone talking about a little device that he came up with that sort of helps you with your running gait. And hopefully everyone is enjoying British Science Week, and we'll see you back here tomorrow at 10 o'clock. And we also have a session tomorrow afternoon as well. Okay.
Is that Laura from Greenology?
That's Laura. Yeah.
Laura is well worth watching.
Yeah.
Laura's a really good speaker.
Yeah, she turned down James Bond for tyres, a recycling plant in Edinburgh. So I'm sure she's got a very interesting story to tell. So that's at 1 o'clock tomorrow afternoon. So thanks again, Paula, and thanks to everyone who's watching.